All right, guys, we are continuing on with differential equations, and we're just going to take a look at some different ways this can come up. It's going to have the same ideas as last class. Hopefully you remember the order of what we should be doing to solve differential equations. First, we should separate variables. And what's always going to happen is we're going to have the y's and the dy's on the left side. And on the right side, we're going to have the x's and dx's. So that's what we're going to end up having. Then, after we separate variables, we need to integrate both sides. And there'll be a plus c on this side from the integral. We will solve for c using the initial condition, which is usually a point they give us. And then finally, we solve for y. And we get points along the way for each of these steps. This is a ton of points on the AP exam for what is one single problem. And I will tell you, this is something with practice that everybody gets very good at and gets these points pretty easily. This is one that you can definitely get 9 out of 9 points on the AP exam. Okay. So let's look. How is this slightly different from yesterday? Well, yesterday we usually had it written as dy dx, and I think it's worth changing everything to dy dx if it's not already like that. So you could leave it as y prime, but I think it's worth changing this to dy dx equals, and then having these be x's and y's also. So this is x's and y's. Notice over here, we can change this to dy dx and then change this to y, and then it'll look exactly like what we're used to, and that makes it kind of nice. The reason is because algebraically, it's pretty easy to see how you can multiply both sides of the equation by dx to cancel this out and move the dx to the right side. It's pretty easy to see how you can multiply by y on both sides to do this. I should have said, when we separate variables, we only use multiplication and division. So only multiply and divide to separate the variables. So go ahead and try to solve this on your own. See what you get. Hopefully you remember it from yesterday. And so we're going to multiply by dx to get the dx on the right side. That'll get rid of it in the denominator. We're going to multiply by y to get rid of the y in the denominator. And so we're going to end up with y dy equals 5x squared dx. Okay. And let's see. We can do the integral of both sides now. So that's what we're going to do. We're going to do the integral, the antiderivative of both sides. The antiderivative of y is y squared, and we have to divide by the new power. We don't put the plus c on this side because it'll combine with the plus c on the other side. Here, the x's will go up by a power, and we divide by the new power. And here's our plus c. So we've already gotten some points. We've gotten points for separating variables. We've gotten points for doing the antiderivatives. Now we're going to solve for c using the initial condition. So here it is. Here's that x and y. When x is 1 and y is 1, what is c? So when y is 1, 1 squared is just 1. When x is 1, 1 cubed is just 1. I actually really like it when x and y are 1 and 0 because it's really easy to plug in. The arithmetic is really nice. So this is 1/2 equals 5/3 plus c. Now we need to solve for c by subtracting 5/3. And that's c. Now, this is actually the most annoying part of this problem right here is actually combining these two. So these have different denominators. We need to get a common denominator of 6. So we'll multiply by 3/3 here and 2/2 here. That way they both have a denominator of 6. We'll get 3/6 minus 10/6. So that's -7/6. That's c. And so now we can plug that back in to our c and get 1/2 y squared equals 5/3 x cubed, and the c is -7/6. That's another point for solving for c. The last step is always solving for y, so we need to do some algebra and solve for y. Y is getting squared here and multiplied by 1/2, so we need to multiply by 2 first to get rid of the 1/2. 2/1, so 2 times 5/3 is 2/1 times 5/3, which is 10/3. 2 times 7/6 is 14/6, which simplifies. We can divide by 2/2 and get 7/3. So 14/6 is 7/3. And then the last step I'm going to go up here is to take the square root on both sides. Now we need to remember, when we take the square root on both sides, it's plus or minus the square root. So 10 thirds x cubed minus 7 thirds. And to figure out whether it's plus or minus, we need to use the initial condition. And what we're looking for is, okay, is the y going to be positive or negative? Well, it has to go through the point 1, 1, and since the y has to be positive, so y is above 0, and so we know we need the positive one. So the answer is y equals square root of 10 thirds x cubed minus 7 thirds. And we knew it had to be the positive one because the y value in the initial condition was positive. If this had been 1, -1, then we would have used the negative square root. All right, try one on your own. Let's see how we do. Try this on your own, solve for y, and at the end, instead of having y equals, so you're gonna get y equals something, make sure you're writing f of x equals because it started with f prime of x. Another thing you can do to not have to rewrite it like that at the end is to at the very, man, this is a little bit low down. Let's pull this up, I keep getting off the page. You can also like write y equals f of x at the very beginning, and then you can use y or f of x whenever you want. So this is a nice trick. So go ahead and solve it. And I'm going to change this for my work. You didn't have to do this. dy dx equals square root of x over 2y. So I'm changing f of x into y's so I can do some of these operations. So now I need to multiply by dx on both sides to cancel this out. And I needed the y on the right side, so I'm also going to multiply by y. I could multiply by 2y if I want. In fact, sure, I'll multiply by 2y to not have a denominator. But I didn't have to. I could have left it be like 1/2 square root of x. So when I multiply by this on both sides, the dx's will cancel, and we get the 2y's will cancel, and we'll get 2y dy equals square root of x dx. We need to next do, so we've separated our variables. The y's and the dy's are here. The x's and the dx's are on the right side. We're going to do the integral of both sides. So the antiderivative of y is y squared, and we have to divide by 2. So it's just y squared. 2 divided by 2 is 1. Here, this is x to the 1/2 power. So when we raise the power by 1, it's going to be x to the 3/2 power, and we have to divide by that. So 2/3. And there's a plus c. This is a great time to plug in and find c. So when x is 1, y is -12. So -12 squared is 144. 1 to any power is just 1. That's nice. And this is a little bit ugly, guys. I'm just gonna, I think, leave it as -2/3 rather than like trying to get thirds and maybe mess it up. I'm just going to leave this. Remember, on the free response portion of the AP exam, you don't have to simplify. So I'm going to leave it like this and plug this back in. So y squared equals 2/3. I'm going to rewrite this. Square root of x cubed plus 144 minus 2/3. And I'm just going to leave that c unsimplified. You could simplify it. It's fine. So now y equals plus or minus the square root. We have to take the square root of both sides. 2/3 square root of x cubed plus 144 minus 2/3. Make sure that that whole side is inside the square root. You have to do the square root on both sides. You have to do the square root of the whole side. And last, we need to decide if it's plus or minus. And so we're going to look at the initial condition. When x is 1, y is -12. Here, y is less than 0. Y is negative. And so we're going to need this -1. I'm going to go ahead and rewrite it at the end as f of x. But if we left it as y equals and we put y equals f of x, that would be fine too. So f of x equals negative square root of 2/3 square root of x cubed plus 144 minus 2/3. And again, I could have combined these, but I chose not to here. All right, hopefully you feel pretty good about this. I do want to point out you don't have to change to dy dx equals. Like, you know, it's completely acceptable to multiply by f of x. And so then you've got f of x, f prime of x equals 1/2, you know, square root of x. And, you know, is this a little bit weird? Sure, but this is just chain rule. Like, this is like our u, and here's the du right there. And so when you undo it, when you do the antiderivative, it's going to be 1/2 u squared. And you'll do the antiderivative here too. If we had multiplied by the 2, it would have come out exactly the same thing. This is just y squared, right? So if you choose to leave it, it's just a reverse chain rule where the derivative of the inside is that f prime of x. But I find it much easier to switch it to dy dx equals for these types of problems. Your choice though. All right, number 3. This is a different type So I just want to show you some steps that are different. We still need to get all the x's on the left and the y's on the right. Sorry, all the x's on the right and the y's on the left. So we're going to multiply by dx. And how do we get the y's on the left? Well, we need to divide by y. Now, when we divide by y, we have dy over here, right? And we're going to have dx over here. When we divide by y, we don't really want to put dy over y. That's a little bit weird. And so we'll just put a 1 here to divide by. 1 is getting divided by y. So when we divide by y, we can move it to the other side in that way. Okay, so what are the antiderivatives here? Well, the antiderivative of 1 over y is natural log of absolute value of y. And over here, this is x to the 1/2 power, so we're going to raise the power by 1 and divide by that power. Dividing by 3/2 is the same as multiplying by the reciprocal, and multiplying and dividing will cancel out. So we get this. Okay, now this is going to look a little bit different. We're still going to plug in when x is 0, y is -4. So natural log of absolute value of -4 equals c. And absolute value of -4 is just 4. So this is natural log of 4. That's where that absolute value comes in, because if you didn't have the absolute value, you couldn't do the absolute value of -4. Sorry, you couldn't do the natural log of -4, it'd be undefined, but when you do the absolute value, you can do the natural log of 4. So here's c, and something cool is going to happen when we plug it in. So natural log absolute value of y equals 2, I'm going to rewrite it as square root of x cubed plus natural log of 4. Our next step is what? How do we get y by itself here? Well, it's natural log of something, so we need to undo that by doing e to the power of both sides. We need to be a little careful here. It's e to the power of both sides. Here it cancels out the natural log. We get absolute value of y. Here, we need to use a property of exponents. And this is going to come up a lot, so you might want to make sure you feel comfortable about this. E to the a plus b is equal to e to the a times e to the b. This is from Algebra 1. When you multiply two exponentials with the same base, you add the exponents. And sometimes that's useful in reverse. When you have two things adding, you can split it up into two different exponentials that are multiplying. And watch how nice this is going to be. This is going to be e to the 2 square root of x cubed times e to the natural log of 4. And what will always happen in this kind of, a lot of times c will come out to be natural log of something, but when you split it up into this multiplying, you've got e to the natural log of 4, and those are inverses, and you'll just get 4. So it's just multiplying times 4. And we almost always just put that in the front. So this is 4e to the 2 square root of x cubed. And this is pretty nice, right? Now, we had this absolute value here. Remember, that's going to turn whatever y is positive, and so y could either be positive or negative, just like with square roots. When we solved absolute value equations back in Algebra 2, we said if you had the absolute value of something, I'm just going to really briefly remind you, if you have absolute value of x equals 7, then x could be 7, or x could be -7, because either way, the absolute value will turn it into positive 7. So x is plus or minus 7. So when we get these ones where we do the natural log, it's possible for this to be either positive or negative, and just like before, we'll use our initial condition to see whether it's positive or negative. In this case, y is less than 0, so it's going to have to be the negative one. Y has to be the negative one. So y equals negative 4e to the 2 square root of x cubed. And there is our solution to our differential equation. Why don't you guys try one on your own? Try number 4. This one's written as y prime. I'm going to change that to dy dx. I think it makes it a little bit smoother, but you don't have to if you don't want to. Now I need to get the dx's on the right side, so I'm going to multiply by dx. So I'm going to multiply by dx, and I need to get the y's on the left side, and here x is multiplying by y minus 1, so I need to divide by y minus 1. And here this is just x dx. All right, so that's the separating variables. Now we need to do the antiderivatives, and here this is clearly a u substitution. U is y minus 1, so we're going to get 1 over u, and du is the derivative of y is just 1. So we've got 1 over u du, and the integral of that is natural log of absolute value of whatever the u was, so y minus 1. We didn't have to, if this had been like 2y minus 1, we would have had to have divided by the derivative of the inside, but here the derivative is just 1. So that's nice, we didn't have to do a lot. But don't skip over that u substitution step. Again, if this had been 2y minus 1, things would have come out differently. Here we've got x squared, and we have to divide by the new power, and here's the plus c. So let's solve for c here. When x is 0, y is 5. So natural log of 5 minus 1 equals c. So 5 minus 1 is 4, and then absolute value of 4 is still 4. So c is 4. So let's plug that in. Natural log of absolute value of y minus 1 equals 1/2 x squared plus 4. Plus natural log of 4. And then to undo the natural log, we need to do e to the power of both sides. But again, remember, this is e to two things adding. This is the same as e to the 1/2 x squared times e to the natural log of 4, and that will always cancel out. So here we've got absolute value of y minus 1 equals, what is this? This is we had 4 e to the 1/2 x squared. Okay. Now, this means that y minus 1 could be plus or minus this, but it needs to go through 0, 5. And since this needs to equal 5, this needs to be a positive. So this is just going to be positive 4 e to the 1/2 x squared. We don't really need to worry about that, because like if this was negative, how would you ever end up equaling positive 5? It wouldn't be possible. So y is equal to 4 e to the 1/2 x squared plus 1, and we knew this had to be positive because of the initial condition being greater than 0. Okay, great. That's all of that. Let's try another one on your own. So we're just going to try some different ones. Here we've got, this is a differential equation. It involves a derivative. It's not necessarily dy dx equals, but it involves a derivative. Determine the solution that would pass through. Here's our initial condition. So what do we need to do? Well, we need to separate variables. Go ahead and do that. What is the correct separation of variables? Well, the y's need to come on the left. That's multiplying by y. So we're going to get y dy. We're going to multiply by dx to get it on the other side. And then how do we get this to the other side? Well, we need to divide by this because this is multiplying. So we're going to divide by x squared minus 3. And so we're going to get 1 over x squared minus 3 times x, right? And pretty clearly, we've got, we've got a u substitution thing going on here. U is going to be x squared minus 3, and du is going to be what? Well, it's 2x. So when we divide x by 2x, we're going to end up with just 1. So this is, I'm going to actually do u substitution. This is 1 over u du, but we had to do 1/2. Because when we divided x by 2, so x divided by 2x, that's 1/2, and that's where the 1/2 is going to come outside of this. So we've got the integral of y dy equals this guy, so 1/2 y squared equals the integral of 1 over u is natural log of absolute value of u. And I'm going to substitute back in my x's. It was x squared minus 3. So 1/2 y squared equals 1/2 natural log absolute value of x squared minus 3 plus c. And let's solve for c here. When x is 2, y is 5. So 25 halves equals, when x is 2, we get, what is this? X was 2, so 4 minus 3 plus c. 4 minus 3 is 1, and the natural log of 1 is 0. This is saying e to what power gets you 1? E to the 0 power gets you 1. So this whole thing becomes 0. So c is 25 halves. Hopefully we feel good about our natural log skills, our log skills, and our ability to solve there. So there's that c. We're going to plug it back in. I'm going to write that over here. Okay, so we get 1/2 y squared. I'm taking this from here. Equals 1/2 natural log absolute value of x squared minus 3 plus 25 halves. We're solving for y, so we should multiply by 2. And that'll cancel out the 1/2. Y squared equals, it'll also cancel out the 1/2 here. natural log of absolute value of x squared minus 3. Now, this was a binomial. So this is one term, this is one term. They're both getting multiplied by 2. It'll cancel out the 1/2 here, and it'll cancel out the dividing by 2 here, which is nice. Last step, y equals, we have to take square root on both sides, plus or minus square root of natural log, absolute value of x squared minus 3 plus 25. And the question is it positive or negative? Well, the initial condition, y is positive, and so that's what we're going to have there. So y equals square root of natural log absolute value of x squared minus 3 plus 25. Okay? Hopefully this is just like a lot of algebra. And if your algebra is pretty good, and it should be coming in through this year, it should have been pretty good coming out of Algebra 1, much better coming out of Algebra 2, and hopefully you got even better last year in pre-calculus. Number 5, another differential equation. Part A says, describe all points in the xy plane where the slopes are positive. This does not say to solve the differential equation. It doesn't say to find the original function. Instead, it asks where the slopes are positive. Now, on the differential equation free response problem, solving the differential equation is always worth between like 4 and 7 points, okay? But there's a couple extra points missing. And so the question is, what sort of questions will they ask you? Well, remember that a differential equation is telling you about the slopes. So some common questions they can ask you are questions about the slopes, question about a tangent line, because the derivative can tell you what the slope is, right? So like the slope of this. You'll use the initial condition. Oh, you guys can't see this. You'll use the initial condition plus the slope from the derivative to find the tangent line. Sometimes they'll also ask you for the second derivative. So you'll need to find the second derivative using implicit differentiation. So it'll be like you would do product rule here. And remember, anytime you get dy dx, you actually plug it in with what the original dy dx is. It's almost always in terms of x and y. So these are kind of like the other one is a slope field. So these are kind of the like other questions that come along with differential equations free responses. We talked about slope fields yesterday. Let's look at some slopes ones. Here to ask where the slope's positive. That's saying the derivative is above 0. So here's an equation for the derivative. Here's an equation for the slopes. Where are they going to be above 0? And when you're multiplying, you really want to make a sign chart. Like x squared is going to be positive unless x is 0. When x is not 0, this will always be positive. And so then the question just becomes, well, when is this positive? Because we want a positive times a positive to make a positive. And so it's when y minus 1 is greater than 0. So when y is greater than 1, and remember, x couldn't be 0. So x squared will be positive. A negative times a negative is a positive, and a positive times a positive is a positive. But if x is 0, 0 times 0 would be 0. And that wouldn't be positive. So y is greater than 1 and x doesn't equal 0. So we're describing all the points. As long as the y values are above 1 and the x's aren't 0, all the points in this place will have positive slopes. And that's super powerful that this differential equation can tell us this, right? We can see that all the slopes will be positive as long as, because x squared is always positive or 0, right? As long as y minus 1 is above 0, we'll have a positive times a positive, and that'll give us a positive. And so that's where the slopes will be positive. So we could have also asked, they could have asked, where will the graph have horizontal tangent lines? And that would be looking for where the slopes are 0, right? And so it would be where x is 0 or y is 1. We could be looking for where the slopes are undefined, and that would be if there was like a division, it would be where the denominator is 0. So anyway, so these questions can come up sometimes. Part B, find the particular solution. And guys, this is the phrasing we want to be used to by now. The solution to the differential equation is, with the initial condition, f of 0 equals 3, this is the part where it's saying solve the differential equation. The solution to the differential equation means find what y is equal to. So go ahead and do that here. This is the more important points one. So I'm just going to rewrite it. dy dx equals x squared times y minus 1. Y is on the left side, so divide by y minus 1. There's nothing here to divide, so 1 over y minus 1 dy equals, we have to multiply the x's to the other side, x squared dx. X's are always on the right, y's are always on the left. And let's do an integral. Man, this is very similar to the one we just did. This is a u substitution, but the derivative of the denominator is just 1. And so you don't really need to divide by anything because it doesn't do anything. So it's just like it was 1 over y. Natural log absolute value of y minus 1, because u is y minus 1. If you did it with the u substitution, it'll come out the same way. Here, x cubed, divide by 3, plus c. And we're looking at the point 0, 3, when x is 0, y is 3. Oops, y is 3. So let's solve for c here. Y is 3. X is 0. So natural log of 2. Notice I don't have the absolute value bars anymore because 3 minus 1 is 2. Absolute value of 2 is just 2. We can simplify the absolute value. C. So we'll plug that in. Natural log absolute value of y minus 1 equals 1/3 x cubed plus natural log of 2. To get rid of the natural log, we do e to the power of both sides. Absolute value of y minus 1 equals, I hope you can see what's going to happen. It's going to be this, so you can skip this step if you want. You don't have to write this step. Times e to the natural log of 2, and this will always just become 2. So 2e to the 1/3 x cubed. You know, if you feel good about that step, you don't have to actually show this. Now, does this need to be positive or negative? Well, y needs to be a positive 3, and so this will be the positive. So y minus 1 equals, absolute value would have a positive or negative, but this needs to be the positive one because y is greater than 1. 2e to the 1/3 x cubed, and so y equals 2 1/3 x cubed plus 1. You know, one question they haven't asked in like 20 years, but could be on this, is they could ask you for the domain and range of the solution, and we'll talk about that next class. Now, I would like you to try a full free response on your own. Set a timer for 15 minutes. Try to get as many of these. Oh man, I want to zoom out just a little bit. I'll attach the document. Try to get as many points on this as you can. Do all 3 parts. Part A is to sketch a solution curve going through the point. Okay. B is to write an equation for the tangent line and approximate f of 0.2. And part C is the particular solution, find the particular solution. So try this on your own, pause it, print out the page, try to do it on your own. So here's a slope field. This is what all the slopes look like for these slopes, right? It gives you an initial condition, f of 0 equals 1. F of 0 equals 1. There we go. And then it says, sketch the solution curve through the point 0, 1. Now remember, the solution to a differential equation is what function has these slopes. Plotting all the slopes can tell you all the different solutions, but remember there are an infinite number of them because of the plus c. So you just kind of follow the slopes here. It doesn't actually matter exactly where you go, just that you're like following the slopes, right? So this is like, okay, I'm just kind of like following which direction the slopes say to go. And it looks something like this, right? I don't know exactly what it looks like, but I know it looks something like this. And all they're looking to see is like, at any given point, was your slope very similar to what the slope field looked like, okay? So it looks something like that. Like maybe mine was supposed to be steeper here. It doesn't really matter. Like if you drew yours like this instead, you know, you're still gonna get full credit. They're not looking for exact points. They're looking for, did it go through the initial condition, 0, 1, and did it mostly like, if you looked at any given point, would your slopes be very close to what the slopes on the slope field look like? Okay, write an equation for the tangent line. Okay, tangent line is y equals m times x minus x1 plus y1. And this will be our point, and it's going through the point 0, 1. And m is going to be the slope, and so we need to use the differential equation. So here's our differential equation. Going through the point, y is 1 and x is 0. So dy dx is going to equal 3 minus 1, because that's 3 minus y, times cosine of 0. So we really want to write this. Like, you want to write dy dx equals, you can't just write this m out of nowhere. So 2 times 1, so just 2. So the equation of the tangent line is going to be y equals 2, that's coming from this, times x minus 0 plus 1. And if you wanted to simplify, oh man, I'm sorry, that was off the page. 2 times x minus 0, the 2 is coming from the slope here, the dy dx. We use the differential equation to find the slope. Derivatives tell us slopes, and then they give us this initial point that tells us the x and the y. And if you wanted to, you could simplify this to be 2x plus 1. Use it to approximate f of 0.2. So f of 0.2 is approximately equal to 2 times 0.2 plus 1. You can leave it like that, or if you want, you can say this is 1.4. 2 times 0.2 is 0.4, 1 plus 0.4 is 1.4. Great. But if you leave it like this, this gets you full credit. Last, find the particular solution. Again, the differential equation is kind of off the page here. I hope you printed it out. It'd be really hard to do this without printing it out. And so we want to find the differential equation. X's go on the right, so cosine of x dx. The y's go on the left, 1 over 3 minus y dy equals this. This is clearly a u substitution. U is 3 minus y, but this time, be careful, du was negative 1. So when we do the integral of 1 over u du, we also need to divide by a negative 1, and that's going to change things. This is the integral of cosine. The integral of u is negative natural log of absolute value of u. Here we've got sine of x plus c, and negative natural log absolute value of 3 minus y. We divide by negative 1 to get rid of the negative that's in front of here. So negative natural log becomes just natural log, 3 minus y. And we're going to divide, oh wait, we forgot to solve for c, guys. So bad. What was the point? 0, 1. So we're doing it at 0, 1. So when y is 1, we get negative natural log of 2, because 3 minus 1 is 2. Sine of 0 is 0. And so c is negative natural log of 2. So we can plug that in. Okay. We'll come over here. Negative natural log absolute value of 3 minus y equals sine of x minus natural log of 2. That is my equation I need to solve for y. Divide by negative 1. This will be negative sine of x plus natural log of 2. Do e to the power of both sides. Here that'll cancel that out. Absolute value of 3 minus y equals, I'm just going to do the trick where I know it's going to be e to this times e to this, and e to natural log of 2 is just 2. And now the absolute value, this will make this plus or minus. I need to decide at the point 0, 1, y is going to be positive, and so I need this to be positive. So 3 minus y equals 2e to the negative sine of x. And I knew this was positive because of the initial condition. Let's solve. Minus 3 on both sides. Y equals negative 2e to the negative sine of x plus 3. And guys, if you didn't do the u substitution correctly and you didn't divide by that du, you would end up with an answer that's kind of close to this, but not right. So make sure, if you're actually doing your integrals carefully, and if it's a u substitution one, make sure you're dividing by your du. So score how many points you got on this free response problem. You want to get, after we've done this for a little while, you're looking for 7 or more points out of 9. You might not be at 7 or more points out of 9 right now because we're only on our second day of this. But after your homework tonight and your lesson next class and your homework next class, really, these differential equations, I hope you can see how these points can just be gotten every time, okay? Have a great rest of your day, guys, and we only have one more lesson after this for the year. Crazy.